Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cindy.
And I'm Kennedy. For math homework, help call in Bakersfield 636-4357. For everywhere else, 1-866-636-6284. Email is dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done, Kennedy. So, Kennedy, where do you attend school and what grade are you in?
I'm 4th grade and in Stockdale Elementary.
All right, so have you been at Stockdale for a long time or just a little while?
Since TK.
Since TK. All right, so you've been there for a while. So as a 4th grader, you now go to school longer than you did last year.
Yes.
Yes, he says. Do you like that?
Not really.
Not really. You know what? I don't think I would prefer that either. It's like, why do I have to go to school longer, right? But guess what? When you go to 7th grade, guess what's going to happen?
Oh, no.
Yeah, you're going to go to school even longer than that, right? And then when you go to high school, guess what?
Oh, no.
You're going to go to school longer than that. So you might as well get used to it now. But since you're in 4th grade, you probably have more opportunities to do things at school that you didn't have at 3rd grade.
Yeah.
So what are some of the things that you have opportunities for, or anything that you're doing that you like in 4th grade that you weren't able to do in 3rd grade?
I'm able to do science fair, and I really prefer that more
good. Okay.
than just staring at it.
All right. So you like doing science fair, and I think
Yeah.
you guys just did your science fair, right? What was your project? Would you mind telling us about it?
It was like, how do disinfectants affect germs the best, and yeah.
Okay. So were you proud of what you did? You felt good about your project?
Yeah.
Good. Well, I'm glad you had an opportunity to do that because that's one of the things. I think science fair, oral language, band, choir, all that kind of stuff starts coming up in the next couple of years.
Yeah.
All right. Well, good. You know what? We have a blast from the past coming up later on today. But before we do any of that, you are going to help me do a social media problem of the day. Are you ready?
Yep.
All right. Let's take a look at it together. We're going to look up here. It says order from greatest to least. Now, these are, and I believe you're working with fractions in 4th grade now, right? You started doing these?
Yeah.
So can you read those 3 numbers for me, those 3 fractions?
1/2, 3/4, and 2/3.
Okay. So it says order from greatest to least. So how do you think we should go about this?
Like, compare them, and then, like, in the end.
Okay, so how should we compare them? Do I just look at the numbers on the top, the numbers on the bottom, or what do I do?
You would take 2 numbers, and this butterfly method is like the denominator to the numerator, and like the other thing, and then like 6, for example, 1/2 and 3/4. 3/4 it would be 6, and 1/2 it would be 4.
Right. Okay, and I understand what you're doing, right? You said butterfly method. All right. So for the kids that are watching going, I don't know what you're talking about, right? Just eliminate the 2/3, right? So what we're going to do is we're going to take the numerator of 1 and multiply it by the denominator of the other one. So 1 times 4 is 4, and that will go above the 1/2, correct? You take the 3 and multiply it by the denominator of the other one. 3 times 2 is 6, and 6 would go above the 3/4. And 6 is greater than 4, so 3/4 is bigger than 1/2. Good. But we have 3 of them, so how do we compare them now?
So then you would like eliminate the least, and then compare it with the other number, and then that
Okay.
number compared like with the least, and then.
All right, so we know 1/2 is less than 3/4, right? So let's take a look at 3/4 and 2/3 and compare those. What would you get?
So 2/3 it would be 8 because 4 times 2, and for 3/4 it would be 9 because 3 times 3. Like.
Good.
Yeah.
Okay, so you feel pretty good that 3/4 is the greatest out of all of them?
Yep.
Okay, so now let's compare the 1/2 and 2/3, right? Okay, so what do you think you got there?
So 2/3 would be 4, and 1/2 would be 3, so 1/2 is the least.
Okay, so we know that 3/4 is the greatest and 1/2 is the least. So 2/3 is going to be in the middle. Have you ever heard about getting a common denominator?
Yes.
Okay, so we could do that with 2, 4, and 3. Do you think you know right now off the top of your head what would be common denominator for 2, 4, and 3? A number that 2, 4, and 3 could divide evenly into.
Yes.
You know what that is?
12.
12, right? So we could turn them all into 12s. We could also, like Willie in the back, and I did this myself, we converted the fractions into decimals. So 1/2 would be what as a decimal, do you know?
1/2.
Like what percent? Like if you got half of everything, what percent would you have?
50.
50%, right? If we had 3/4 of something, what would we have?
75.
75%, right? And 2/3, about what would that be?
Like, I don't know.
Okay, but thirds, right, we go like 33, 33, 33, right, to cut up 100, right? So it'd be 33 and a third. So 2 of them would be 66, 67, right? So if we had 50, 75, and 67, it would still work out in that same order. So we have at least 3 different ways that we could solve that problem. So based on what you said that 3/4 was the greatest and 1/2 was the least. So out of A, B, and C, which one do you think is the best option?
A.
You think A is? All right, let's take a look and see
Wait,
if
no.
indeed A is correct. All right, there you go. First problem done. See how easy that was?
Yep.
All right. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, today's Math in the News has to do with it's an event that's going to be coming up. And I had asked Kennedy, and she was kind of familiar. So, Cindy, are you familiar with cicadas?
A little bit.
A little bit. What do you know about them? Or what?
They're noisy.
Okay, they're noisy, which is kind of what Kennedy was bringing up also, all right? So, cicadas are periodical insects that spend most of their lives underground feeding on tree roots. So they live most of their lives underground, all right? And they eat roots. So there are 2 different broods. They will either stay underground for 13 years or 17 years. Then what they do is they come out and they mate for the last month of their life, and then they die, all right? So some people are like, wow, what a way to go, you know? It's like, all right, so yeah, I lived for 13 years underground, I come out, I'm alive for a month, I see everything, and then I'm done. Well, that's the way it goes with Mother Nature this time. So this, every 221 years, that's a long time, isn't it? Because it only happens every 221 years where 2 broods will come out at the same time. And 2024 is one of those times. And we can see on the map, so here's one brood, right? Brood 13, and this is brood 19. And they're a little bit more spread out, right? But when you have all of them together, right? So right here, right? This is where you're gonna have a lot of noise in the next couple of months, all right? So we can see, so I pulled this up. People are like, well, how loud is it, right? So what they do is they have a tymbal muscle that they're contracting, and it goes anywhere from 120 to 480 times a second. They're vibrating this, which makes that sound continuous to what we hear, okay? The soil needs to be about 64 degrees in order for these things to come out, right? So if it's too cold, they won't come out. So in that part of the country, it's going to happen around April, May, when it's going to get warm enough for them to come out, okay? So it's going to happen somewhere between April and June. By July 1st, they're gone, all right? Because by June, they're up and mating, and probably before then, even that. But you can see where this is going to happen, the different broods, right? So 2024, right, there's 13, and this one is 19, right? So we can see right in here, this is where this is happening, and that was all that spread out. The next time, so the last time this happened, 221 years ago, do you know who was president?
George Washington.
That's a good guess. That's a good guess. Thomas Jefferson.
Dang.
All right. Thomas Jefferson is known for getting a major part of the country, the Louisiana Purchase. Okay. And he got that from when Napoleon was in power. And the thing is that, and people don't believe this or something, they go, yeah, you throw that in there, right? Napoleon was so sick of listening to the cicadas, that's why he gave the Louisiana Purchase for such a great deal to the United States and Thomas Jefferson. And that is today's Math in the News. Pretty cool, huh? All right. Anyway, that is today's Math in the News. 636-4357 is the phone number. All right, you ready to do some math now?
Okay.
All right, head on over to the board. You and Cindy are going to work on this. So, you've done some excellent work with fractions already, but you said that you're working on adding them and stuff with like denominators. All right? So let's go 3/6. That's all right. You can erase it and then start over again. So 3/6 plus 2/6. So solve that and explain to Cindy what you're doing.
So basically, since the denominators are the same, they don't change. It's just going to be 3 plus 2, which is 5. So it's 5/6.
So you're going to add the numerators, but you're not going to add the bottom, the
Yeah,
denominators.
All right, so how about this? Let's go 3/6. So write it again, a different problem. Plus 4/6.
So since it's basically going to be 7/6. If we're going to use mixed numbers, since like it would take one whole and then leave one behind, it would be 1/6, or it could just be 7/6.
Okay, so just maybe explain to me, like, so you started off with 7/6, and then when you said it can be one whole, how many sixes would one whole be?
So a whole would be 6/6. So you would
Okay.
have to turn that into like a whole, and then you leave.
So that's where you got your one
Six.
from, for the people that are not sure, right?
Yeah.
Yeah.
All right, so you seem to be pretty comfortable with what you're doing so far. All right, so why don't you erase all of that, if you remember how to get rid of it all. There you go. All right, so 3/6 is a nice one. Let's start with that again. 3/6 plus 4/9, 4/9.
Okay. So this one's a little bit different, right?
Yep.
How's it different?
The denominators are different. So.
Okay. So I know some people will just try to just start adding everything up, but are they correct?
Nope.
Okay, so you need to make the denominators the same, right?
You have to, a common denominator, which is
So you're thinking of your multiples of 6 and 9,
54.
and the least one they go into. 54 is one of them, but can you think of one smaller?
36.
Even smaller. That's another one, but there is a smaller one.
Okay.
If you just start, just think of your multiples of 9, and then the first one that 6 can
Oh,
also.
18.
There you
18,
go.
Okay.
You could use the others, you just have more simplifying to do in the end.
So then it would be 18, and you would add them.
Okay, so before you add the top, I keep saying top, numerator, because you're changing the denominator, right?
Mm-hmm.
We have to figure out, so if this is 3/6, what is it out of 18? So we have to make it equivalent. So how many 6s does it take to make 18?
3.
So we multiply that by 3, so we would change this.
So maybe
By multiplying
rewrite
it
them
by 3.
underneath the equivalent
Yeah,
fractions.
so down here, just write the equivalent fraction for it.
So it'd be 18.
So the denominator will be 18?
Okay. Just
And then the numerator is going to be, so the denominator would be, the bottom would be 18.
okay.
You're fine. And then like you told me, you had to multiply that by 6, so by 3, so you would multiply that by 3 to get to your new numerator. So what is 3 times 3?
9.
Yeah, so your equivalent fraction is 9 out of 18. So let's do the same thing here. So 9 times what number will give you 18?
2.
Right. So we would multiply the 4 by 2 to get an equivalent fraction.
So it'd be
Right. And now we can add it. $17 out of 18. Good.
So you feeling pretty good with that now?
Yep.
All right, good. Erase the board. Always a better one coming up.
I don't know.
So let's stick with our 3/6.
Okay.
And this is going to be fun. Plus 5/4.
Let's not worry about the fact that that's improper right now. Let's do that at the end.
Hurting me.
So thinking of your multiples of 6 and 4, what's the
It-
first
it-
one
it
they
would
can
be
both?
12.
Okay, good. So like last time, we want to make equivalent fractions. So we want to make this become something out of 12.
So it would take 2, so this would be 6
Good,
over 12.
yeah.
And since it takes 3 to get to 12, this would be 15.
Good.
This is hurting my brain.
You got the hang of it. You're doing good.
So,
So now you can add it up.
so this would be 21/12, but like it's improper and hurting my brain, so you would get rid of this mess.
Okay.
And then like you would change this into like a mixed number, like, right?
You can do that there, or you could do it at the end. Is 21/12 kind of too big to make you think of it?
Yep.
Okay, yeah,
So-
you can
so
change
then
it there
it-
and
it
then
would-
re-add it.
And then it would become 1. Just one second. Three.
Good,
Three.
yeah, mhm.
So then that would turn into 9 over 12.
And don't forget the 1.
1.
There you
9
go.
over 12.
Now, have you learned how to simplify the 9/12 part?
Yes, but I forgot.
So what number can divide into both 9 and also into 12?
It,
So not what they
It's
divide
the-
into, what divides into 9? What can 9 divide by?
it's a prime number. It can only divide by 1 in itself. It's 3,
Forgot
3,
three.
3, 3.
Yeah, so you can divide both of these by 3 to simplify. So your whole number stays the same, your 1 stays the same. You just write it next to it over here.
So this would be 3.
Uh-huh. And then
For
12 divided
4.
by, yep, there you go.
Okay.
So then that would be your final answer.
There you
Simplify.
go, nicely done. So
Good job.
all of the problems that you've just done are things that you're going to do in 4th grade, maybe, but guess when you're going to do them? In 5th grade, you're definitely going to be
for
doing
sure
a
in
lot
fifth
of those problems. So I'm glad you kind of got
Yeah,
the
you
hang
got-
of
and
it
you
and
caught
worked
on
on a
quick.
few right there. For your great efforts so far today, you got yourself a meal courtesy of our friends at Chick-fil-A, so congratulations on that. 636-4357 is that phone number, and I know that you were talking about how you were learning how to use a compass today, correct?
Yep.
And working with circles and measurements, and we're going to talk about circles right now.
Hello, my name is William Plink, and we're back with Do the Math. Today we're going to be explaining the area of a circle. Now, area of a circle is much different compared to your average square, which is length times width. That has almost nearly nothing to do with the circle. So you're going to have to get rid of this and start from scratch. First thing you need to know is how radius and diameter are different. Now, radius is the distance between the center dot, or just the center of the circle, to the edge of the circle. Now, I'm not a perfect straight liner, so those who have OCD, don't blame me. So that's what a radius is. So that in math, that's typically classed as r. Now, in a diameter, which is different for calculating different parts of a circle, is from the one edge of the circle to the other. So now you know the difference between the two, so we'll get into the area. Now, area of a circle equals r squared times pi. Now, r squared is just any radius times itself. So now we have our little equation here, we'll start with our problem. So we're trying to figure out what this shaded area is. So we have the radius of 4, and we're trying to figure out, that. So first we have to figure out what the circle is. So take our little handy dandy equation here. We can just plug it in and do 4 squared times pi, or 16 pi. So 16 pi is the total area of the circle. But, that's not really necessary for knowing how to do the entire, this little quarter here. That's the word I was looking for. So it's fairly simple. Just divide by 4 and you get 4 pi. So now we have 4 pi. So since we know what this is, we can figure out what this is. And it's fairly simple. You see, a square, length times width, but a square has perfectly 4 sides. So you just square the number. So 4 squared equals 16. And if we want to get the little shaded area that is very odd, and you'll see why in a minute, you get 16 minus 4 pi. And I feel like the takeaway from this is that not all answers are cut and dry as you may think. Sure, you can go into the depths of calculating 4 times pi, but pi is an infinite numbers. It will keep on going on and on and on. So in math, don't always think for a clean and cut answer, but rather an answer that could be a clean and cut answer. I guess what I'm trying to say is that the answer will not always be the answer you think it would be. Now, this answer was just from an SET question that I saw that I feel like explains a lot about circles. Now, the next time you see a problem similar to this, just know that 4 pi and remembering the radius. I'm William Plank from Do the Math. Goodbye.
And thanks to William on that, a nice little explanation on parts of circles right there. In studio with us right now, we have Zane Adamo. How are you?
Good to see you.
Nice to have you.
Thank you.
And nice to have you back.
Yeah.
So a lot of people are like, what do you mean back? Well, how long ago was it when you were first here?
Well, I started working here senior year of high school, I think, so getting close to 15 years. It's probably about
that
12,
old?
12, yeah.
That means I'm a little older too
Old,
then
yeah.
right now. All right.
It's probably 12 years, 13 years now.
All right. So if I'm not mistaken, I believe you were one of our first student employees of the year,
Yeah.
right? And
Yeah.
what was your role while you were here at Do the Math when you started with us?
Well, when I first started, I was on camera 3.
Right. I
there in the
remember you on a
corner.
camera.
Okay, earned my stripes, and then went to camera 2 and 1, then floor director, and then in the back over there.
All right. So how long were you here altogether? I mean, do you remember how many years that was?
It must have been 4 years because I went to BC for 3 years before I transferred to CSU Monterey Bay.
Okay.
And I worked here
The
senior
whole
year
time
until
while
I
you were
left,
here.
yeah.
Okay. Yeah. So it's funny because it seems like a lot of kids, they started on camera 3.
Yeah.
Right, and then you moved over. There's 3 main ones, and it's like, oh, I got the camera 1 finally, right?
Yeah.
And as you can see now, there are no kids behind cameras. No. Everything is operated in the back,
Yeah.
which is where you ended up.
Yes.
Right. So how did you like that whole experience?
Oh, it was great. You get to see how the whole show ran, and it's great, starting on camera 3 and learning what, all these things do, and it makes into one show. And then once you get to the point where you're able to take on the show as a whole, you kind of know what's going on from start to finish.
It's funny that you started working on camera 3, and you're here to talk about cameras right now.
Yeah.
Maybe not video cameras, but photography. So how long have you been a photographer? I mean, I know a lot of people, I've been taking pictures for a long time. I remember when I was 4 or 5 and whatever, but that's not really thinking about what you were doing. And so how long have you been into photography?
Well, my dad worked at the Californian, Felix
Right.
Adamo, for close to 40 years. So cameras, all that kind of stuff.
Were always around.
Always around. And then I would say, I think people have different definitions, but I considered myself a photographer in 2020 when I went full-time freelance and was doing that for a living and working for a living.
So a lot of kids will be watching, and they're probably junior high and high school and stuff. Did you ever do anything like yearbook, where you were doing photos for schools and things like
Yeah,
that?
I went to BHS and I was on the blue and white for 2 years, 3 years. And,
So
and
I
then
take it the blue and white is like the yearbook or the newspaper, or something
there, yeah.
there? Okay.
Newspaper, and then I also did the video yearbook when I was at BHS as well too.
All right, good. So let's talk about exposure.
Mm-hmm.
So one of our first slides here. So what would you like to share with us about exposure?
Yeah, well, there's 3 things that go into exposing an image. ISO, used to be called ASA, aperture, and shutter speed. And all 3 of those parts of the exposure triangle that you see here will affect how your photo comes out.
Okay, so here's another question for you. Do you ever remember, or did you ever have to develop film, or have you totally been digital?
All digital.
Okay.
I remember my dad.
So you don't remember the good old
No.
days. Well, you probably remember them with your father
Yeah,
doing
yeah.
stuff like that. But okay, I was just curious if, I was like, well, you're pretty old, but you're not that old now that you've never had to deal with film.
No.
So let's take a look at the ISO.
Mm-hmm.
So, and we can see here the different numbers.
Yep.
And the range is, right, so it looks as though they're just doubling.
Yeah.
Okay, so kids can see that, all right? All right, yeah,
Yeah.
they double, and that's a sequence, a pattern that people will be able to see.
Mm-hmm.
But can you tell us a little bit about the slide we're looking at and
Yeah.
what it means?
So ISO 100 would give you a very clean image, no grain, no noise. So in the film days, there would be film stock. So there'd be like 400 that you couldn't change it. So if you had film that was 400 or 800, that's what you had.
Okay.
Whereas digital cameras now, you have a huge range of ISOs you could choose from.
And obviously, the film that you had would cost based on what you were getting
Yes.
also, right?
Oh yeah.
So
It's
if somebody
different.
was just like an amateur, just wanted to take some photos,
Yeah.
they wouldn't be spending the kind of money as somebody else with a different level.
I think there was a personal choice. I know, talking to my dad, that Kodak's Tri-X, I think 400 was one of his favorites to use.
Okay, and do you have one that you use all the time, or that you like more?
I
or-
don't shoot film, but the same principles of film apply to digital. And so when you go higher ISOs, you have higher grain or higher noise. So if you want a clean picture, you want low ISO.
Okay, all right, let's take a look at the next one here. So the aperture, and a lot of these are probably terms that some students have heard, but they're not really sure what they mean.
Yeah.
Which is why we have you here today.
Yep.
So f-stop. Okay, so talk to us a little bit about, because this must be the lens that we're looking at up
Yeah.
on the top right
Yeah,
there. And so we've got an f2. So what is an f2 as opposed to, say, an f8? So obviously we can see that one is more wide open, I
Yes,
guess.
yeah. So if you're shooting in a darker environment, you want to open up your iris or your f-stop wider so you can let in more light to expose either your film or your sensor that you have in your camera. And I know there's like a mathematical equation about the numbers, but I don't know. It's
Okay.
a little above my head. But depending on where you go with your f-stop, it will also affect how your photo looks. And so right here, depth of field is also affected by your aperture as well.
Okay, because yeah, you can see in the background how it's pretty blurry or fuzzy.
Yeah, yeah.
Right, and then it's clear
Yep.
based on the f-stop. All right. So on a camera,
Yep.
so can you tell us a little bit about where some of these things that we've been talking about so far?
Yeah. So this camera is kind of unique. It's a digital camera, but it's kind of modeled off of an old film camera.
I was going to say, it looks like one of the older ones.
Yeah, so it's a rangefinder style camera. Then right here too as well, there's the f-stops that you can pick from. So right now it's at 4, f4.
Okay, so before we get moving it around a lot, I think camera 3 is the one that you're going to want to, and we'll take a look and they'll kind of zoom in a little so that they can see.
Yeah, there's a bunch of numbers on there.
So the numbers that the kids can see right now. So let's take a look and let's talk about these ones right here.
Yeah, so that would be your shutter speed. So I have an option to go up to 4,000ths of a second and then all the way down to like 8 seconds. So if I'm doing like nighttime photography or something, go up from
That's
there.
when you would want it. Okay.
Yeah.
And then you were talking about the f-stop, and those are the numbers that we're looking at up here.
Yeah, that's
Okay.
the f-stop. And then the ISO that we just talked about, that's controlled in the camera since it's digital.
Okay. So you've got the camera.
Yep.
And you're looking at something. So let's say you take a picture of Sophia Sophia, right?
Yeah,
So
yeah.
you're looking, and based on the distance, right? So now you're manually
Yep.
Okay.
take a camera, and
And
take a
then
picture.
with the digital, now you can see. So can you manipulate that right then and there, or
Yeah.
do you have to wait to download it to be able to manipulate
No, you
it?
can adjust, and that's what's nice about digital is you can see what you just took, unlike in the film days.
You had to just hope that when it was developed, it came out the way you
Yeah,
wanted
and then
it to
you also knew, I think what's interesting about film is you had to think about what you couldn't just take a photo just off the cuff. You kind of had to know about what you were going to do, what your settings were at, and that's what this light meter kind of comes into handy for.
be. Okay, so
as
let's
well.
talk about this right now.
Enter camera 3. So yeah, this right here, it gives you a reading based off of an f-stop. So this one's made exactly for film cameras, but you can still use it for still cameras. And what you can do is see what a properly exposed image would be based off the settings that you want.
Okay, so how would you use that right now to do something in here?
So if I wanted to take a picture of you right here, what I would do is, so I have my ISO, I want to shoot at 800 ISO at 125th of a second. And so I would put this up to your face and click it. And so it's telling me if I want you properly exposed, I need to be at f2. Right?
Okay, so that will tell you how to set the camera.
Exactly, yep.
Okay.
Yep.
Well, good. So that's a handy tool to have.
It is, yeah.
And you use that pretty regularly, or after a while you kind of go like, I kind of know what I need to be without having to check all the time?
Yeah, so this is something that, I don't see on photo shoots or film shoots very often because for the most part with monitors and screens in the back, you can kind of basically figure out where you need to be. But this
Okay.
is a little bit more kind of like you want to be very specific about light ratios. So if I wanted to take a picture of you and make it look the same at a different area.
So somebody, a student might be like, yeah, I want to get into photography a
Yeah.
little bit, and I've got a camera and I'm kind of learning how to use it. Cameras, obviously, there's a wide range in prices that you can
Yeah.
use. But let's say somebody wanted to use something like that to help them get a little better at their photographs. How much are we looking at, or is there a wide range in those as well?
They can range pretty from
So let's say you just want a basic one for a kid to kind of get started.
probably a couple $100, and then also I've seen
Okay.
light meters at like thrift stores and antique stores you can get for even cheaper too.
Okay,
They're
so
not
that would be
digital,
an
though.
idea to
Yeah.
kind of look for things like that. All right, I do believe we have one more slide to look at here. Shutter speed.
Yeah.
So tell us a little bit about this and the slide that we're looking at.
Yeah, so the shutter speed is the speed which the shutter clicks and exposes the image. And it kind of depends on what you're going for. So if, for instance, if you want to take pictures of a football player or a soccer player, I always think of you want your shutter speed to be around 250th of a second
Okay.
to capture that motion and not have them be blurry, unless you're going for that.
So if you were going to take a photograph of me as I was moving down, I would be like on the far right there. I'd be like a blur to you, right?
Yeah. If I was at 1/4 of a second.
I'm
Yeah.
moving so fast, it'd be like a blur going, hey, what was
Yeah.
just that going by? That's
Yeah.
just an old man moving, that's all right, don't worry about that. All right, so obviously you've been doing photography for a long time. This is not only a hobby, I mean, an occupation for you as
Yeah.
well.
I tell people, I went to film school, but there's a lot of things that photography and film have in common. And so I do both regularly. And it's something that you can do as a hobby and also do as a profession as well, too.
All right, good. Well, you know what? We certainly do appreciate you taking out some time to come visit
Thank you
us.
for having me.
Welcome back, and maybe you can head in the back and see what's going on. And you'd be like, hey, helping out the kids that are back there and stuff like that. All right, 636-4357 is the phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays. In studio, we have Kennedy, a 4th grade student from Stockdale Elementary, working on fractions and decimals as well. So we're going to put you ladies back to work. Are you ready?
Yep.
All right, let's take a look at another one. So actually, one that I'm going to take out right now is we're going to take a look in your math book, and it says write as a money amount and as a decimal in terms of dollars. So let's find a good one. Oh, because I guess we'll just start with the first one. 25 over 100. So write down the fraction 25 over 100. They want you to write it as a money amount and as a decimal in terms of dollars.
Okay, so tell us what you're thinking since you're just
So,
going straight
since
for it.
Since it's like 25 or 100, 100 is going to be $1 since it's 100 pennies. So it would be 25 over 100. So 25, it would necessarily be a quarter, and that's not a dollar. So it'd be $0.25. So,
Okay.
and decimals is basically the same thing, except this isn't a thing.
So just maybe write it next to it, so you have both answers there. So 25 hundredths written as a decimal is the same as 25 hundredths, which are written as a fraction is the same as 25 cents.
Yeah.
All right, so you feel pretty good with that?
Yep.
All right, good. Erase that, we're done with that. We're not even gonna keep going with other problems like that because you've already got it. But one of the other things you said was you were starting to work with circles and measurements and things like that.
Yep.
All right? So, Cindy, what I'd like you to do is with Kennedy, talk about different types of angles, such as obtuse, acute, right angles, measurements of them, things like that, all right?
Okay. So what did you learn so far with the circle?
So
You were
this-
using a compass, right?
Yeah.
Did
Just,
you?
we're learning about like acute angles,
Here, why don't you
obtuse
maybe
angles.
write them up here so everybody can see.
Like
on the
we're
TV.
learning about like acute angles, and we're learning
Okay.
about like obtuse angles,
Okay.
and also right angles.
All right.
And
Do
we're
you
also-
know how any of these measurements work? So what's a right angle measurement?
It's 90 degrees.
Okay.
It,
And then you said the word acute for that one.
it would be less than 90 degrees.
Okay. So smaller than 90 degrees. What about this one? What'd you call it?
So it's called obtuse, and it would be like over 90 degrees.
Okay. So if you had a 89.5, what would you call it? Degree
89.5.
angle. Yeah.
That would be acute.
Okay.
Since it's still less than 90
So
degrees.
I have one more word for you. Let me see your pen. What if you saw this? That angle. What do you think on that?
It's 180 degrees.
Okay,
It's
so-
like it's just like a straight line in like the.
Yeah. Do you know what it's called?
Damn.
You actually said the word. It's called a straight angle.
Yeah.
Yeah, because it makes a straight line. And so, because it's almost like you put two 90-degree angles back to back. Oh, I guess I have my own pen right here. Huh?
Yes.
Like that, right?
Yep.
So if you look at like here's 90 over here and here's 90 over
Like
here.
for example, it's a cross. It's all 90 degrees.
Good. Yeah.
It's all 90 degrees.
Okay. So she's got some angle names down. What else
All right,
did you want
good.
us to go over?
So you've got those all well. So let's try different types of triangles.
Okay. So you got the names of the angles.
Yep.
All right. So we'll talk about different types of triangles based on how their angles measure. Okay. So what do you think an acute triangle would have?
So it would either have 89.9 degrees to like 0.
So it would have acute angle.
Yeah.
Okay.
That would be it.
Do you think, so if I drew like one acute angle here and I wanted to make it into a triangle, I would have to connect it like this, yeah?
Yep.
Is there any way I could get, well, this would be an acute angle, one example of an
Yeah.
acute angle, where is all of them are less than 90.
Mm-hmm.
So if I went and I drew a triangle that looked like this,
That's an obtuse.
so there are
Well,
some
there-
acute angles in there, right?
Yep.
But it's not called an acute triangle anymore because they're not all acute. So what does it have that's different?
It has one obtuse angle.
So what do you think that one's called?
The obtuse triangle.
Yeah, exactly, exactly. And then, oh, that wasn't very good. Hold on. Well,
You trying to do this?
yeah, where this is like, do you know what that little mark means?
Right angle?
Yeah.
So it would be like a right triangle.
Yeah, exactly, exactly.
Good, so you've classified triangles by angles.
By angles.
Now let's classify triangles by sides.
All right. So triangles have other names too,
Yep.
based on how their sides are related. Do you know any of them already? I'm just curious what you know so far.
Really?
Not really? That's fine.
sure.
Let's talk. Okay, so if I had one where, let's see, I have to try to draw it and make it look, you know,
Make it look magical.
well, I didn't do a great job. I'm gonna put these little marks on here just because at your, like at fourth grade, you might not see the marks, but because I didn't draw it perfect, marks mean that these are all the same length. So I can tell I kind of made that a little longer than I needed to, but if those were all the same lengths, that's called an equilateral triangle. Have you heard of that before?
Yes.
Yeah, so lateral means the sides, and then equal, so equilateral triangle. All right, and then there's one where you have two equal sides, and then another side. So that wouldn't be equilateral anymore because they're not all the same. So this would be like this if I was to mark it off. That one's called an isosceles triangle. Have you ever heard of that?
No.
No. So an isosceles triangle is when you have two equal sides. So if I have do you know what a triangle adds up to? Have you ever learned that before?
Like it's just like up to 3 sides. It's
Well, I mean for the angles, I'm sorry. That's what I meant. The degrees of the angles.
kinda.
Okay.
Like
So if you haven't learned that before, like all of the angles add up to 180 altogether. And so if you have an equilateral triangle, that makes these angles also have to be the same measurement. Otherwise the sides couldn't be the same length. So these would be like 60 degrees, 60 degrees, and 60 degrees. If you have an isosceles triangle, then this angle and this angle are automatically going to be equal to each other. And then you have one where it's just all different. Let's see. Okay, I have to make it work here. Where they're all different lengths, and that's called a scalene triangle.
Good. And I know these are pretty new to you and stuff, but I just wanted
you
you
don't have
to
to
be
memorize them
exposed
today.
to them right now. Not that you have to have them memorized, but you will be getting to these things later on during 4th grade. All right?
okay.
So there you go. Nicely done. And right now we're going to check out what's going on this week at NASA.
The latest private astronaut mission to the International Space Station, preparing to launch more research to the space station, and how climate change is affecting our oceans and atmosphere. A few of the stories to tell you about this week at NASA. On January 18th, Axiom Mission 3, the third private astronaut mission to the International Space Station, launched aboard a SpaceX Dragon spacecraft from our Kennedy Space Center. The mission is commanded by former NASA astronaut Michael Lopez Alegria. NASA will provide integrated operations support, which starts during the Dragon's approach to the station, continues while the crew is aboard the orbiting laboratory, and concludes when Dragon leaves the area of the space station. The research heading to the International Space Station on Northrop Grumman's 20th Commercial Resupply Services mission to the space station for NASA includes the first surgical robot on the station, an inexpensive orbit re-entry platform to collect thermal protection systems data, and a new metal 3D printer. Northrop Grumman's Cygnus spacecraft will launch atop a SpaceX Falcon 9 no earlier than January 29th from Cape Canaveral Space Force Station. Our Plankton Aerosol Cloud Ocean Ecosystem, or PACE mission, is targeted for launch no earlier than February 6th. The Earth Observing Science mission will help us understand how our oceans and atmosphere exchange carbon dioxide, measure key atmospheric variables associated with air quality in Earth's warming climate, and monitor ocean health. We resumed a critical test series with our RS-25 rocket engine on January 17th at our Stennis Space Center. Data from the testing will be used to certify production of new RS-25 engines to help power our Space Launch System, or SLS rocket, on future Artemis missions to the moon and beyond, beginning with Artemis 5. That's what's up this week at NASA. For more about what else we're up to, check out nasa.gov.
Always interesting things going on at NASA. And as a matter of fact, I know there are a lot of 5th grade students going down to the Jet Propulsion Laboratory tomorrow for a field trip. So a lot of exciting things going on that they'll be able to see down there. In studio with us, we have Kennedy, a 4th grade student from Stockdale Elementary. And Kennedy has been there since TK, and you're pretty comfortable at the school, right? You're used to it and stuff like that? All right, good. So we'll see how comfortable you are with this, all right? So you're in 4th grade, so we're going to do a thing called 4-4s. Have you ever done this before?
4/4?
Yeah. You're looking at me quizzically, so I'm going to say, excellent, you haven't done it yet. So this is perfect. All right, so Cindy, go ahead and put 4-4s up there for me. So Kennedy, while Cindy is doing this, do you have any idea what the order of operations are, or what that means when I say that? The order of operations.
Not really.
No, good. So this is something even better for you. So you and Cindy will talk about this. So before we even do the 4 fours, Cindy, why don't you take a quick minute and do a very simple problem, just showing the order of operations without exponents and stuff like that.
Okay. So if there was a math problem and it looked like this.
Now I can remember.
Okay. And you were to apply the order of operations, there's a certain order that you need to do math problems in. It's not like reading a book where you just go left to right and you read your page. You have to know what things are more important and come first. So you always start with your grouping symbols, so the parentheses in this case.
Yeah.
So this sounds familiar to you?
Yeah, so we're doing 6 divided by 2 first.
Okay, so in the parentheses, so it goes grouping symbols. So I'm gonna write, whoops, I'm just gonna write the parentheses. And then it would be multiply or divide would be next. And then add or subtract would be last. So add's not gonna happen first. We do have parentheses, and in the parentheses we have both of these operations. So which one comes first?
This.
Yeah, so you're correct
So
that you do.
so this would be 3. So this would be 6. So 2.
Wait, so before, because I know where you got it from, but just to make sure someone's not lost if they're watching. So how did you get 6? What'd you do next?
So now that you have this problem gone, it's like all that. So now you have just 3 plus 3.
Oh, so you did this and just jumped ahead to that.
Yep.
Okay.
So it's easy. 2 plus 6 would equal 8.
So you brought the 2 down and you added it up and you got 8. Okay, so you're
Good.
a little bit familiar with the order of
All right,
operations.
so we're on our way. So erase all that stuff at the bottom. And Kennedy, I would like you to select a number between 1 and 10.
5.
5. All right, so at the end of the 4s, I want you to write an equal sign. At the end of the last one, put equals and then put 5. So you have to use the 4 fours. And you can put operation symbols like add, subtract, multiply, divide, parentheses, anywhere in there. But you have to use all 4 fours to make them equal to 5.
Okay.
So you and Cindy go ahead and work on it, but it's mostly you.
I have
All right? So
beautiful
tell her any ideas you
You have a
have.
beautiful plan. Let's hear it. Okay,
Yeah,
so we have to use
flat.
4s though, is the only thing that's wrong with your beautiful plan. We have to
Right,
come
so
up
you were on a
with, we
roll,
have
I
to come
saw.
up with what goes inside between here. So we want to do like 4 plus 4 minus, we want to try to figure out where to put the operations with just 4s. So like
So
this,
you
this
can't
be a
use the 2 and the
we
1.
can't- We could use this 4, but we have to.
Dang it. My beautiful plan.
Your beautiful plan. Okay, so let's just go ahead and let's just work it with this. What's here? So just put some operations in and let's see what happens, and then we can maybe think a strategy to change it around.
So
So you're trying to get it to 5, okay?
we're just using all 4s and somehow by the magic.
So we're just putting like some math in between them, or parentheses if we want. So what math operation you want to try to put in there first?
Maybe divided.
Okay.
I don't know.
So we got divided, all right?
So that would be 1.
So we know this part would be 1, all right? Keep going.
So that would be 1.
Just put some other things in there and then
Right.
let's just work with it. And maybe we can just rearrange something. Okay. So 4 divided
Yeah,
by-
it's just wrong. It's wrong. So
Okay, so what would this equal, just so we can adjust from there? So 4 divided by 4
that would be like 8 or something.
is 1, and then 1 times 4 is 4.
So
Yeah,
that'd
it
be
would be
8.
8,
That
so
would be
it's a little
8.
bit big, all right. So let's just maybe, raise some operations and try something else.
I just wish I could turn this into a 1. I just wish I could turn this.
Just that number, just that one number right there. Here, let's just get rid of these and then let's just try something else. All right.
So no idea.
Well, I mean, we have multiplication we can try, we have subtraction, we have division. We used addition, I think, and, okay, so we got,
16.
all right. 16
That's an
so far.
excellent first step right there, I can say.
Okay.
Okay. Thank
Ooh, I
you.
think I kind of see where he's going. Yeah, okay. See if you can see it.
Don't see it.
Okay, well, that's an excellent
Don't-
first
I
step.
don't see it.
All right. Thinking of what can make 5, that includes a 4 in it. What can make 5 with like something, operation 4 equals 5?
I could go 9 minus 4 is 5.
9 minus 4 was 5, that would work. But could we get a 9 from these two? Because we could then minus 5, minus 4 and get 5.
Maybe.
16. What else could equal 5? Maybe it's not minus, maybe it's not 9, maybe it's something else. Or just put something on there and let's try it.
Just random.
Okay, so then what's 16 plus 4? If you just look at what you got so far before you figure out what goes next. Okay, what's 16 minus 4?
That would be 12.
Okay.
Then minus 4, that would be.
So I'm going to give you a clue. You were getting warm, now you're getting cold.
Yeah.
Oh, yes, let's play that game. Let's play that game.
Okay. So what do you think you meant by that? What did you just have there right a second ago? Before you put the minus on, or the subtraction on. Do you remember?
Addition.
Yeah,
Addition.
yeah. Put your addition on there. Right here, on this one. Keep your 16. You want that. 16 is a good start. Okay.
Gosh.
Okay, but
Okay,
now,
like,
before we finalize that, do you need any other thing in it to make it work properly with the order of operations? So right now, if you did order of operations, there's no parentheses, so you'd start with which one?
Wait.
So let's
Dang
just
Dang it.
keep it. Watch. I'm gonna
Right,
show
so
you.
what I'm going to do is I'm going to have you girls keep working on that because everything you've got up there is correct so far. But you need to modify it a little bit to make sure that it works correctly. While you're working on that, we're going to find out a little bit more about forest services.
In this episode, we'll look at how field treatment areas on National Forest System lands changed the intensity of the Caldor fire and allowed for community defense. But first, what's a field treatment area? A field treatment area is a location where the Forest Service or our partners have reduced or removed the amount of burnable material, specifically surface and ladder fuels. This can be completed by mechanical equipment or prescribed fire, or what we really like, a combination of both. It also includes ecological thinning, the removal of whole trees to increase crown spacing and reduce tree densities. The combination of these field treatments reduces the chance of a fire moving from the ground up through the shade-tolerant species and into the crowns of the trees. And if it does get up there, it further reduces the chance of a fire moving from crown to crown to crown and a high-intensity fire. You can see in this field treatment area, there's not much surface fuels, no logs, no big sticks, there's no ladder fuels, just big tall trees with some black on them. You can tell this area has been treated with prescribed fire and ecological thinning. Right now, I'm standing in a field treatment area that helped to protect communities of Pollock Pines, California from the Caldor fire. During its first week of rapid growth, the Caldor fire continued to move to the east and north, pushing right to where we're standing and the communities right across the street. This field treatment area provided our firefighters an opportunity to use a specific tactic known as a backfire or a firing operation. A backfire is a careful, planned, and deliberate process by which firefighters deliberately set fire to fuels to slow down a rapidly approaching fire. You can see the firefighters started right here on the edge of this containment line. So they're bringing fire away from the neighborhood and into this fuel treatment area. It did burn a little hot, but nowhere near as intense as the head of the fire. And when you look up, the crowns of the trees are all still here. This backfire essentially created a buffer of very little burnable material between the active Caldor fire and these communities. It takes professional, well-trained firefighters to engage in a firing operation such as this during a dynamic incident like the Caldor fire. In this case, it was the El Dorado National Forest hotshots, but a key component of that strategy was this fuel treatment area. This zone, free of most burnable materials, gave those firefighters the opportunity to utilize a tool that may not have been available if this treatment hadn't been completed. Over a week later, the Caldor fire spotted into the Lake Tahoe Basin, really close to where we're standing right now. It first spotted in untreated forests, and firefighters on the ground reported extreme fire lengths over 100 feet tall. As the fire approached the communities and neighborhoods of Myers, California, it first had to cross through the fuel treatment area that we're standing in right now. When a high-intensity wildfire enters a fuel treatment area, it can significantly reduce the flame length due to the lack of hazardous fuels. That's exactly what happened here. Firefighters on the ground reported a change in flame length from 100 feet outside the fuel treatment area to 20 feet. This created opportunity, along with bulldozers, to create containment line and directly attack the fire. Not a single home was lost in South Lake Tahoe. You can really see it right here. This fuel treatment area allowed the flame lengths to come down, so our firefighters could build this containment line to protect these homes. In both of the examples we've spoke about today, it was the bravery and professionalism of firefighters on the ground that protected the specific neighborhoods of Pollock Pines and Myers, California. But it was also the fuel treatment areas that provided that opportunity. Thanks for watching.
And some great information right there. A lot of times people go, well, why are they setting more fire when there's a fire going on? Perfect explanation right there for it. Kennedy was working on 4.4s, and you did come up with the proper solution with the parentheses on top. And down below, explain what would have happened if you didn't put the parentheses.
So 4 times 4 is 16, so yeah, it's 16 at the bottom. The adding is basically saying it's a different problem and you're supposed to bunch it together. So 4 divided by 4 is 1, so if you bunch it together, it's 17.
You can see that 17 isn't correct if you wanted to get 5.
Yeah.
All right, nicely done. So Kennedy, did you learn a little something today?
Yes.
Good, I'm glad you did that. You probably learned quite a few things. Did you have fun while you were learning it today?
Yep.
That's the more important part right there. Hey, don't forget, we do have phone tutors available most Tuesdays and Wednesdays between 3:30 and 5:30. Phone numbers at the bottom of your screen periodically throughout every program. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.